Hello everyone, welcome to Aerospace's YouTube channel. So this particular channel will be dealing with aerospace content, and we'll be starting with the course that will basically familiarize everyone watching this video with what exactly aerospace engineering is, what it deals with, all the concepts in aerospace engineering. So let us start with this course introduction, a very simple course introduction. What exactly aerospace engineering is. We'll deal with some of the basics, and then after this particular video, the next video, we'll be dealing with the individual concepts. Okay. So what exactly aerospace engineering is? So aerospace engineering is a branch of engineering that deals with the design, development, testing and production of aircraft, spacecraft, satellites and missiles. So particularly the words that we are using to describe aerospace engineering, it's a branch of engineering, we all know that, which deals with design. So design aspects of aircraft, of spacecraft, satellites and missiles. All these four will be dealt under the broad topic of aerospace engineering. So it includes design, that is basically planning how exactly this particular machine would function, where it would function, what is its mission, etc., etc. And then coming to the development basically means how the design phase is executed, how exactly it is planned to made. Then coming to the testing phase, where exactly the prototype or the model of the particular machine is tested. And then coming to the production phase, that is basically the manufacturing or making the machine. So that's how aerospace engineering is defined as. So basically, it involves the application of principles from physics, mathematics, and material science to understand and optimize how objects move through Earth's atmosphere and outer space. So basically, aerospace engineering focuses on both aeronautical engineering as well as astronautical engineering. So that is why we have highlighted aeronautics as well as astronautics. So aeronautics, you can see in this particular image, so all the planes, all the rotorcrafts, helicopters, etc., whatever you can see which is operating in the Earth's atmosphere, within the boundary of the Earth's atmosphere, is known as aeronautical engineering applications. And then coming to the outer space, that is basically which is operating outside the boundary of the Earth's atmosphere, is known as astronautical engineering. So it basically involves spacecrafts as well as the satellites that we have already put into orbit. So next, what are the divisions in aerospace engineering? So basically there are four main divisions in aerospace engineering. The first one being structural engineering or structures. So this particular branch of aerospace engineering deals with the structural analysis, structural integrity and testing and many other things that are basically related to structural aspects of an aircraft. So basically, let us say there are different types of parts and how these different parts are arranged, what type of loads they can take, and what are the different design aspects related to those particular parts will be dealt under structures. Then coming to aerodynamics. Aerodynamics is basically a study of flow of air around the aircraft. So the aircraft can go at different speeds. So aerodynamics is divided into different types of aerodynamics depending upon the speed of operation. So there can be subsonic aerodynamics, supersonic aerodynamics, and hypersonic aerodynamics, which will be dealing in the later parts. Then coming to propulsion. Propulsion is basically the means by which an aircraft will move through air, or it is the force. Propulsion is basically a theory in which we are trying to generate a force through which we can move the aircraft or the spacecraft through the air or in space. So there are different kinds of propulsion, that is air breathing propulsion and non-air breathing propulsion, which we'll be dealing in the further sections. But what is necessary to know is that propulsion is basically a branch which is for propelling the aircraft or the spacecraft in air or in space. Then coming to control. Control is a branch which is mostly related to electronics or aviation electronics, that is avionics. But this particular branch, which I'll not be dealing in my YouTube channel, but you can find other resources to study this, and this is mostly studied by non-aerospace engineers, so we'll not be going much deeper into this branch. But there is something related to controls which is called stability, which we will be dealing, because that is one important aspect in aerospace engineering. So let's go through all of these in the further videos or upcoming videos basically. Now let us come to what are the forces on an aircraft. So basically, there are four forces that are acting on an aircraft. The first force, which is the weight of the aircraft, very simple to understand. Aircraft has some mass, so because of that, there is some weight which is acting downwards because the Earth's gravity is acting downwards. So this is the weight vector. Always remember one thing, that these vectors should be as long as it is needed. The lift vector should be longer than the weight vector. The thrust vector should also be longer than the drag vector. So this is one thing that needs to be kept in mind while drawing. But right now, just for understanding purpose, what we can do is the weight vector, which is pointing downwards, is basically the mass of the aircraft. The gravity is pulling this aircraft downwards. So this is one particular force that is acting downwards. The other force that is acting upwards, which you can see over here, is lift. This is basically the force that is keeping this whole aircraft in air. And then coming to drag force. Drag force is basically counteracting the aircraft. It is trying to pull the aircraft back in air so that it does not move forward. That is because basically because of the resistance of air and the resistance of this particular body when it is moving through air. Air does not allow this particular body to move forward. That is the reason there is a drag force. Then coming to the thrust force. Thrust is basically a force that is generated by the power plant. So what exactly a power plant is? A power plant is a device that basically generates thrust, or a thrust generator can be termed as many different. There are many different terms to for the thrust generator. So this power plant basically generates a force which is called as thrust, which will help the aircraft in moving through the air. And thrust is basically the force that we are trying to generate using the thrust chamber. Now let us go towards what are the different parts of an aircraft for understanding what exactly aircraft parts are, what their function is. So the first part of an aircraft definitely is the cockpit. So cockpit is the area where the pilots sit in a manned aircraft. There are different kinds of aircraft again, manned aircraft and unmanned aircraft. That is one way of classification. So cockpit is where the human beings or basically the pilot is sitting to control the whole aircraft. There can also be unmanned aerial vehicles in which a human is not necessary, but there can be onboard electronics, and that can also be termed as the cockpit in some cases. Then coming to the jet engine. So here we have a type of engine which is known as a jet engine or a turbojet or a turbofan engine. So this particular engine is necessary for producing thrust. It is mandatory for producing thrust. If this is not present, we basically call this aircraft as a glider and not as a aircraft essentially. But here we have something to generate thrust which is called as a jet engine. In some cases there might be a propeller. Normally propellers are mounted on the nose. They can also be mounted on the wings. Then coming to the wing, this particular part is responsible for generating lift. So wings are responsible for keeping the aircraft in air, that is contracting the weight of the aircraft. This thrust will basically contract the drag of the aircraft that I showed you previously. And then coming to the next part, that is the empennage. So this particular region is called as the empennage. Here there is the vertical stabilizer, the horizontal stabilizer. So horizontal stabilizer is basically used to control the pitch. So we'll deal with what exactly the motions of the aircraft are in the next slide. So there are three motions, that is rolling motion, and then there is yawing motion, and then there is pitching motion. So these three are the primary control surfaces. There are primary control surfaces to basically control this pitch, yaw as well as roll. But what do we need to understand is that basically they are controlled using control surfaces, which we'll be dealing next. So apart from the primary control surfaces, there are also secondary control surfaces such as flaps. They basically change lift and drag again. That there's not much theory that we'll be learning about them, but surely there will be some concepts related to this in control part, that is the stability part. So there are secondary control surfaces includes flaps, the slats, spoilers, etc. The primary control surfaces, as I already said, they are ailerons, elevators, and rudders, which we'll be dealing next. The important part, or basically the part which is very important in an aircraft, is the fuselage. This is what exactly the part which is required in an aircraft to, let us say, to have a mission. We need this particular part. So the fuselage or the body of the aircraft will basically hold things together. That is, it basically houses all these parts are connected to the fuselage. So fuselage basically carries the payload. The payload here can be fuel. In very rare cases, normally fuel is carried in the wings, and normally the payload includes people, that is the passengers that are traveling, or it can also include the cargo in case of cargo aircraft. Okay, so now coming to what exactly the control surfaces of an aircraft are. So there are three control surfaces, or primary control surfaces, what we actually call them. These are ailerons, elevators, as well as rudders. So ailerons are basically responsible for roll motion of an aircraft. As you can see in this particular video over here, this is the roll motion of the aircraft. You can clearly see that what is happening here. The black part that is highlighted over here is the ailerons that are responsible for the roll motion. So the fuselage, the rotation is about the fuselage. Then coming to the pitch motion, you can see what exactly pitch motion looks like, and this is responsible because of the elevators. The black parts here again outlined are the elevators. There are two elevators again. Also there are two ailerons, but rudder, that is singular. That is one thing that's need to be kept in mind. So these elevators are responsible for pitch motion. So the pitch motion is sort of this heaving motion that you can see over here. The fuselage of the fuselage of the aircraft basically oscillates. This is the pitching motion. Then coming to the yawing motion. The yawing motion is basically this kind of motion that you can see over here. The rudder is again highlighted in black color. So because of the singular rudder, there's this kind of motion that is possible. So these are the three primary control surfaces and the three primary motions that you have. There are also secondary control surfaces which we'll be dealing in the later parts, not this video. Okay, so now we know about aircraft. So now let us look at what are the different parts of a rocket. So rockets can again be classified into different types. How we have different types of aircrafts, there are different types of rockets. So there are mainly two types of rockets, that is liquid fuel rockets and solid fuel rockets. So these are the parts of the liquid fuel rockets, and this is the part of the solid fuel rocket. So liquid fuel rocket basically contains two important tanks, that's the liquid fuel tank and the liquid oxidizer tank. So fuel and oxidizer, when they come together, they basically ignite to produce hot gases that is responsible for thrust generation. One thing to notice is that the liquid fuel and liquid oxidizer are basically sent into the combustion chamber using pumps, because these are liquids obviously, and they need pumps in order to be sent into the combustion chamber. There can also be different other mechanisms that can be used to send these liquid fuel and liquid oxidizer into the combustion chamber. Then coming to the solid fuel rocket. So this is quite different from that of the liquid fuel rocket. What we have over here is a solid grain which will be burnt in order to generate thrust. We'll have an in-depth review of this while we are completing the module rocket propulsion, or the section rocket propulsion. Right now, the things to be kept in mind is what are the different parts and how is it different from aircrafts. So one thing to notice is that here we are not using any atmospheric air. So therefore we can term this as non-air breathing propulsion, and that's how it is different from aircraft propulsion. So thank you guys for watching this video. Now let us stop it here and we'll continue it in the next part.